Hi coders, welcome to CS Time channel. In this video, I will talk about how to use binary search in Java. Binary search. Binary search is the search technique which works efficiently on the sorted list. Hence, in order to search an element into some list by using binary search technique, we must ensure that the list is sorted. Binary search follows divide and conquer approach in which the list is divided into two halves and the item is compared with the middle element of the list. If the match is found, then the location of middle element is returned. Otherwise, we search into either of the half depending upon the result produced through the match. Let's see the example. We have a given array here, 1, 2, up to 10. And then the element to search is 3. We can understand from the given array that the elements is in order. Because of that, the best technique to use is binary search. Let's see the visualization. All the elements in the given array occupy a certain index, start from 1 up to 10. So it occupies index 0 up to index 9. To use binary search, I will need three variables. The first variable I need is left to hold the first index, which is 0. And then right variable to hold the last index, which is 9. And then I need also mid index that comes from left plus right divided by 2. So the binary search technique will work by comparing the search to the given array mid. So from this example, left plus right divided by 2, the result is 4. So index number 4 is in here, which give us element 5. So every time we search, we will compare the search to the given array mid, which is 5. When we compare it, there will be three possibilities. The first possibility is the search equal to given array mid, which is the 5. Second possibility is the search is bigger than given array mid. If it's bigger than given array mid or bigger than 5, then the area of searching is on the right. We start from here up to here. The last possibility is my search less than given array mid, which is less than 5. When my search is less than 5, then my area of searching is in here from index 0 up to mid or even before the mid, which is here. So let's see the program. First, we will initialize found with false because we haven't found the data. And then I will initialize left, right with the first index and the last index. And we will keep on comparing the search to the given array mid as long as our searching area is in here. That is why for this situation, I will need while loop. The condition is left less than equal to right. And then now we need to find the mid. The mid is left plus right divided by 2. Once we got the mid, we will compare the search to the given array mid like this. If search equal to given array mid, which is the first possibility, it means we found the element. When we found the element, we need to hold the index. So the index comes from the mid itself. Since I use variable index here, I need to give initialization value to my index. And I need to give output or to tell the user that the element is found and tell the position, which is the index. Once I found the element, then I need to quit the looping. Therefore, I need break. The second possibility, which is this, is we use else and then we compare it. Second possibility, search greater than given array mid. If it's greater than given array mid, then the searching area is here. Since the searching area here, then my left instead of 0, I need to update my left with mid plus 1 because I will start searching here. So left is mid plus 1. The third possibility, then I will need else again here. The third possibility is my search less than given array mid, which is my searching area is in here. Since my searching area is in the left, then my right need to be updated. My right now, instead of 9, I need to update it with this mid minus 1, which is here. So here is the instruction, write equal to mid minus 1. As soon as data is found, then we give output data found and then tell the position of the element. Otherwise, check the second possibility. If it's greater than given array mid, then we will update the left value. Again, if it's not fulfilled, it will check again. If the first condition is not, then the second condition is not, it must be the third condition. So when it fulfills the third condition, then we will update the right value, which is mid minus 1. Once we quit from the looping, then we will check again the found value. If it's false, then we tell the user that data is not found. I use Eclipse as my IDE. And to save time, I already prepared the code and I will just paste it here. Now let's see the code. Here is our given array that I declared as integer. And here is the element, start from 1 up to 10. And then I declare found variable with boolean that I initialize it with false. And I also declare search variable with integer that I initialize it with 3. And then the index, I make it integer. I initialize it with minus 1. And then left variable, I declare it with integer. I initialize it with 0 because 0 comes from the first index of given array. And then the right comes from the last index of given array, which is 9 here. And then mid as integer. And here is my looping. Okay, when left less than equal to right. And then now my mid comes from left plus right divided by 2. As soon as I got my mid value, then I will compare my search to given array mid. The mid here is the index of given array. When we compare it and the search equal to the value in the mid index, then the found, which previously false, we change it to true. And then the index to hold the index of given array, then we initialize the index with mid, and then we quit the looping. However, if it's not equal to given array mid, then another possibility is my search greater than my mid value. If that's the case, then my left should be updated with mid plus 1, which is my searching on the second half or on the right half. Otherwise, which is the last possibility, is my searching area is on the left or on the first half. I have to update my right with mid minus 1. Once it's quit the looping, we need to check again the value of found. If it's true, then we tell it's found where. Otherwise, tell that data not found. Now, let's run the program. We are searching for 3. 3 is in the index 2, 0, 1, 2. Now, let's change it to check one more time. I'm looking for 8, for example. Let's run it, okay? Now, data found in 7. So, it's correct, yeah? 0, 1, 2, 3, 4, 5, 6, 7. So, 8 is in 7th position.
Well, if you learned something from this video, please subscribe and like for more videos. Thanks for watching.